Hello everyone, today we'll learn about how to quickly draw the circle of Willis. Okay, so what we'll do is we'll take a red ink and I'm going to draw the vertebral arteries, the two vertebral arteries over here. And remember, vertebral arteries both should be joining at the junction between the medulla and the pons. Okay, this will be the junction between the medulla and the pons, and they will join together to form the basal artery, which you know, and that will split into two posterior cerebral arteries. So I'm going to label this quickly. This is the vertebral artery, and that will be the V4 segment of the vertebral artery, and this will be the basal artery, and this will be the P1 segment of the posterior cerebral arteries. Okay, this will be the PCA, B is the basilar, and V4 is the vertebral artery. All right, now what I'm going to do is I'm going to take a point eraser and I'm going to make some gaps over here to accommodate some of the branches that are needed over here. Okay, over here you will have the posterior inferior cerebellar artery, which will usually have a characteristic loop like this. Okay, that is the pica artery, and this will be the anterior inferior cerebellar artery. So remember, the pica is arising from the V4, anterior inferior cerebellar artery is arising just after the basilar artery is formed, and just before it divides into the two P1 segments, it will give off the superior cerebellar arteries. Now remember, over here these three are cerebellar arteries. So this is the pica, this is the ica, and this is the SCA, and this C, all these C stands for cerebellar. Unlike the rest of the vessels where the C stands for cerebral, these are cerebellar arteries. And there is a very important relation over here. So I'm going to quickly take a yellow ink over here and mark something here. This is the oculomotor nerve. So the oculomotor nerve will be sandwiched between the superior cerebellar artery and the first segment of the posterior cerebral artery. So remember, it's like this. Suppose this middle finger is the posterior cerebral artery, and this is the superior cerebellar artery, and then this stylus will be the oculomotor nerve. It will be sandwiched between this. This is very important because any aneurysms over here, suppose it is a PCoA aneurysm or a posterior cerebral P1 aneurysm, can compress this oculomotor nerve, which is in close proximity to these vessels. Now let us continue with labeling rest of the vessels. Over here you have the other ica, and over here you will have a lot of pontine branches because the basilar artery will be hugging over the basilar sulcus of the pons. These fine branches are called pontine branches, and over here you will have sometimes you will have the labyrinthine artery. The labyrinthine artery can arise from the basal artery, and sometimes it can also arise from the ica artery. Ica artery is here. So these are the very important branches coming from this much system. This system is formed by the vertebral artery as well as the basilar artery, and together this is called the vertebro-basilar system, also known as the posterior circulation. So remember, in the blood supply of the brain, this much part is called the posterior circulation. The rest is called the anterior circulation. So I'm going to the anterior circulation using another ink, not a red ink, just to contrast between the both. So here you have the internal carotid artery. I'm drawing this as a round because you need to know that here the internal carotid artery is actually coming end on like this, and you are cutting the internal carotid artery. So you are seeing those two rounds that you see here are the end-on versions of the internal carotid artery. So here you are seeing it is dividing into two terminal branches. Okay, this is one of the branches and this is the next of the branches. So I'm going to draw those two branches over here. Okay, these are the two terminal branches that you're seeing. Okay, and I'm going to take that point eraser once again, and I'm going to rub a little bit over here to accommodate another couple of very important branches. I'm going to make a gap over here also. Okay, so I'm going to draw another vessel. This vessel is the ophthalmic artery, which is a branch of the internal carotid artery. Then you have the posterior communicating artery. Okay, this is the posterior communicating artery. It is a branch of the internal carotid artery. It is conventionally thought of as a branch of the internal carotid artery. And then you have another branch. This branch is called the anterior choroidal artery. Okay, don't get confused with the name here. This is called the anterior choroidal artery. So just to clarify, I'm going to label this again. This I stands for internal carotid artery, or the ICA. This stands for the M1 segment. M stands for middle cerebral artery, MCA, and this is the M1 segment, and this is the A1 segment, which is the anterior cerebral artery, ACA. Okay, so that is the A1 segment, this is the M1 segment, and this is the P1 segment, which we already mentioned before. Over here you are seeing the PCoM artery. You have to call it as posterior communicating artery, PCoM artery, to differentiate it from P1, which is posterior cerebral artery. Okay, I hope you understood the meaning of each of these abbreviations. And this artery is called ACHA, which stands for anterior choroidal artery. Now, you shouldn't confuse between anterior choroidal artery and the anterior cerebral artery over here. Okay, so all these are different. Anterior choroidal artery is basically supplying the choroid plexus. It is basically forming the choroid plexus, but it is also important here because it is having a part of the blood supply into the internal capsule. So this creates the majority of the vessels, and we can complete complete the circle of Willis by drawing one more vessel, which is a communication branch between these two anterior cerebral arteries, and that is known as the ACoM, anterior communicating artery. So that completes the circle of Willis. Let us just trace the circle of Willis now. You have to look at the mouse pointer right now. So this is the anterior communicating artery. This is the A1 segment. This is the PCoM segment. This is the P1 segment. This is the top of the basilar artery, and this is the rest on the other side. So if I try to draw the circle of Willis alone, okay, you imagine I'm going to simplify that by drawing the circle of Willis alone. Then this is the ACoM. These two are the A1 segments. Okay, next here you have the internal carotid artery. We know that is the internal carotid artery, and this will be the PCoM arteries, which are branches of the internal carotid, and the rest I'm going to use the red color. This is the P1 segment, and this is the top of the basilar artery. So if you kind of count the sides of the circle of Willis, this is 1, 2, 3, 4, 5, 6, and 7. It is basically not a circle, it is basically a heptagon. That is why some people generally call this not a circle of Willis but as Polygon of Willis, because this is basically a polygon, but this is a heptagon. So you have 7 sides for this circle of Willis. All right, now let us quickly go and revise this. You can see the two vertebral arteries joining together to form the basilar artery. This is the ICA, from where you can see the labyrinthine. Okay, labyrinthine can be from ICA, it can also be from basilar artery. And this is the posterior cerebral artery. This is the P1 segment, and this is the superior cerebellar artery. And this will be the posterior inferior cerebellar artery, as we mentioned before. And these two vessels are the spinal arteries. You have the anterior spinal as well as the posterior spinal arteries. I didn't go to that right now because I'm concentrating on the blood supply of the brain. Now from here you can see the posterior communicating artery arising from the internal carotid. Internal carotid is giving off the two ophthalmic arteries. Okay, that is ophthalmic artery, and these are the anterior choroidal artery, and these two are the terminal branches of the internal carotid. They are the anterior cerebral and the middle cerebral artery. This will be the A1 segment, and this will be the M1 segment. Now just to complete, for completion's sake, after the anterior communicating artery you have the A2 segment, or the second segment of anterior cerebral. Similarly, after the posterior communicating artery joins the P1 segment, you have the P2 segment. Okay, so the segments of each of the arteries is another topic, but I'm focusing on the circle of Willis over here. Now it is also very important to note, to identify that this is the circle of Willis. These were the segments that we mentioned before. You should also know the relation of the circle of Willis, not only just this diagram, but where the circle of Willis is on the brain. So this good image from Jung et al. Shows how it is climbing up the medulla. What you are seeing here is the medulla oblongata. Okay, this is the medulla. This will be the pons, and you can see the pons lodges the basilar artery, and at the top of the pons it will divide into the two posterior cerebral arteries. Okay, here you actually have the pituitary gland, and here you have the optic chiasm. So these two are very important relations. So when you get the brain, suppose you are seeing a specimen of the brain in an anatomy practical examinations, notice the location of the pituitary gland as well as the optic chiasm, which will be located there, and this will be surrounding the circle of Willis, will be surrounding these two structures. So let us have a look at a specimen of the brain, as I told before, to identify these circle of Willis in the specimen. What you are seeing here, this bulge is obviously the pons. So on the pons you have identified the basilar artery trunk, and just after the formation of the basilar artery, you are seeing the anterior inferior cerebral artery, which I mentioned as ACoA. Okay, that will be the ACoA. Here all you will have small pontine branches. Here you can see the basilar artery is dividing into the two terminal branches. They will be the posterior cerebral artery, PCA, and this will obviously be the P1 segment, right? And just before the posterior cerebral artery, you are seeing the superior cerebellar artery, SCA, and this is the nerve that I mentioned before. Between the posterior cerebral artery, P1 segment, and the superior cerebellar artery, you have the oculomotor nerve. Okay, this one is the oculomotor. I'm sorry, I'm using another ink. This one is the oculomotor nerve. Okay, so I'm clearing that much off. Now let us look into this part. This is the internal carotid artery. Internal carotid artery, as you can see, it is end-on internal carotid artery, and it is dividing into its two terminal branches. This is the anterior cerebral artery. See how the two anterior cerebral arteries of both sides are meeting together, and this will be the middle cerebral artery, which is the M1 segment. Anterior cerebral artery here is the A1 segment. And also notice this relation here. This is the optic chiasm. You have to lift the optic chiasm a little bit to see the continuity of the internal carotid into the anterior cerebral artery. That will be very clear once you lift the optic chiasm. Okay, now over here you can also see the posterior communicating artery. This is the posterior communicating artery, PCoM artery, and you can see also the middle cerebral artery, which is entering into the cleft, a large cleft between the temporal lobe over here and the inferior frontal lobe over here. This is actually called the stem of the lateral sulcus, or the stem of the Sylvian fissure. So it is into that the middle cerebral artery is going into. Now you can see within this circle of Willis, okay, within the circle of Willis, I'll use this ink here. Within this circle of Willis, you can see the optic chiasm here. You can see the pituitary stalk here, and you can see the two mammillary bodies here. So all these are very important landmarks which will help you to identify the circle of Willis and its branches. Suppose it is a practical examination in which you are given a specimen of the brain and you are asked to identify the circle of Willis. These are all going to be important landmarks which will help you to identify the circle of Willis and its branches. Okay, thank you.